Welcome, everyone. My name is Ellen Dunham-Jones, and I am your host here of episode 17 of Redesigning Cities, the Speedwell Foundation Talks at Georgia Tech. Here at Georgia Tech, I direct the Master of Science in Urban Design in the School of Architecture. If this is your first Redesigning Cities event, I invite you to visit YouTube, your favorite podcast platform, or our website to check out the videos and podcasts from previous episodes. Now, I do want to, before I talk a little about today, I just want to let you know we have a lot of new episodes coming in the spring. And if you haven't already received, are not already receiving our email notifications, you can sign up at the Redesigning Cities website. Today, our topic is redesigning cities with neuroscience. It's a topic I confess to know little about, but I've already learned so much just by preparing with our speakers today, Sarah Goldhagen, Sonit Bafna, and Harrison Fraker. They will each give short presentations on their work before we dive into a conversation. All of you are invited to post questions in the Q&A tab on the right of your screen at any time throughout the event. And you're also welcome to use the event chat for comments, but we will not be screening that for questions. You're also most welcome to comment on the event on Twitter or Instagram. Now, I'm going to start, kicking us off will be Sarah Williams Goldhagen, and she will be drawing on her award-winning and beautiful book, Welcome to Your World, How the Built Environment Shapes Our Lives. A passionate architecture critic, Sarah is a contributing editor at both Art in America and Architectural Record, prominent journals. Previously, she was the architecture critic for the New Republic and taught for 10 years at the Harvard Graduate School of Design. She sits on several boards, including the academic advisory boards of the Academy of Neuroscience for Architecture. She will be followed by Sonit Bafna. Sonit is my colleague in the School of Architecture at Georgia Tech, where he directs the Ph.D. program. His research consists of both empirical studies on health, behavior, and cognition, as well as very speculative theoretical questioning of the principles that shape the built environment, aesthetics, and representation. He is currently working on a book titled Imaginative Reasoning in the Shaping of Buildings. Lastly, I'm very pleased to include Harrison Fraker in our lineup as both a presenter and a respondent. He is Dean Emeritus at UC Berkeley and winner of the Topaz Medallion, amongst many awards recognizing his longtime success advancing climate-responsive design. His newest book links those interests in climate-responsive design to neuroscience and psychology more broadly. Just released, his new book, Minding the City, Field Notes on Sustainable Public Space, is also a lush delight with a serious message. And with that, I'm going to invite Sarah to share her screen.
All right. Hi, everybody. I started working, just to give a little bit of context to this, I started working on this material about 8 or 9 years ago. I had been teaching at Harvard and before that doing a PhD in architectural history at Columbia University and was very interested in phenomenology. And all of my colleagues, including my professors and my peers and so on, kept telling me that that was a deeply unsexy thing to be interested in. Unsexy because it was so, quote unquote, apolitical. Phenomenology is only about individual experience. It can't tell us anything. Anyway, but I remain really interested because I'm deeply interested in how people actually experience their built environments, whether it be urban landscapes or architectural landscapes or whatever. Okay, fast forward. If we look at how design ideas for the built environment change, like what are some watershed moments and changes in design ideas for the built environment? There are basically three ways in which design ideas, which can be style or other things, construction methods, change. One is through changes in technologies and materials. I mean, the digital revolution had a huge impact on the kinds of forms that people could make. material changes in material technologies, ditto, circumstances on the ground, the pandemic, the most recent one, World War II, sort of huge historical events that don't per se have anything to do with the built environment, but fundamentally shift what it is people need in the buildings and cities that they occupy. And then there's a third way, which is a little bit more subterranean and less well recognized, which is through new streams of information. And that's what we're really talking about here, is the new streams of information. And effectively, to give sort of the most broad brush view, what I want to say is that what used to be called phenomenology, and by phenomenology, I don't mean Edmund Husserl and Heidegger. They're phenomenologists as well, but not the kind I'm interested in or we're interested in. It's really Maurice Merleau-Ponty, who was, in fact, an experimental psychologist. What has happened in the last 20 years is that a lot of information from a lot of different siloed disciplines has flown together to substantiate some of the basic precepts of phenomenology and phenomenological experience of the built environment. Where are those coming from? They're coming from psychology, and there are a lot of different branches of psychology. There's evolutionary psychology, which is actually really important when it comes to the built environment, and maybe we'll get into that. Environmental psychology, ecological psychology, social psychology, so on and so forth. And then there's cognitive neuroscience, which we'll talk a little bit more about, and have the implications of that in public health. And what really precedes some of the work in cognitive neuroscience that pertain to what we do as architects and urban planners, which is studies in cognition. How do people think? How do people come up with the ways that they have and use without realizing that they're using it to understand their immediate environments, to understand their place in the world? And effectively what's happened is that work that came out of cognitive linguistics and in philosophy of mind has begun to be substantiated by work in cognitive neuroscience and in all these different forms of environmental psychology. Just stay with me. I know that this is all quite abstract, but it will become clear. And what the result has been that we now have an emerging new paradigm of how built environments shape human lives. And the short tagline to that is profoundly. They shape the way we think. They shape the way we feel. They shape the decisions we make. They shape how healthy we are or how unhealthy we are. So that's, I would say, writ large, the topic of what we'll be talking about today. To rephrase this in another way, instead of the mind-body paradigm, which is now generally accepted as of about 2 decades ago, that our bodies are profoundly influenced by what our minds think. So if we think all sorts of depressive thoughts, then our body's going to slow down and start having the somatic identifiers of depression, for example. So the mind-body connection is now well established, but we need to pull that out a little bit, because what this new paradigm has showed us is that the real relationship is a mind-body environment relationship, a relationship among these 3 factors that is constantly intertwined and intermeshed and changing. Okay. Now, there are a few things that we can say that are some of the hallmark features. One is that how we experience the built environment, we experience it non-consciously. Cognitive linguists estimate that about 95% of every single thing we think is not conscious, not accessible to or recognized by our conscious thought. Now, this is a slide. I'm just going to go through it very quickly. On the upper left-hand side, you see a window with sort of trees looking out a window. This refers to a study that was done by a I always forget who he was. I think he was an environmental psychologist, actually, who found that patients who had rooms in hospitals that looked out on pastoral views healed over 30% more quickly than patients who had rooms in hospitals that looked out on brick walls. Same surgery, they were controlled for health and so on and so forth. So what I want to do is sort of unpack that study, which is by Roger Ulrich, very famous, 1984, a little bit, and say, well, okay, so what was it about that view out the window that helped people heal so much more quickly? By the way, they also had many fewer requests for pain medication along the way. Was it the horizon line? So these photographs are just meant to emphasize specific aesthetic features of what's in that window and sort of ask questions about them. Was it the horizon line? What if instead of the pastoral view contained only evergreens instead of deciduous trees? Would people have healed as quickly? What if you were in Namibia, where this slide was shot, and you had grown up in a desert landscape? Would you still heal more quickly with a pastoral view with deciduous trees? And the answer to that question, actually, interestingly enough, which has been studied, is yes. Was it simply that windows set and kept rhythm with the patient's circadian rhythms? Which we know is so important for depression, for healing, for sense of well-being, and so on and so forth. Was it, this is on the lower, could you guys see my cursor if I use it? Like there? Whoop, wait a minute.
Yes, you can.
You can see it? Okay, so now I'm on this slide. Was it simply that the trees that they were looking at have fractals in them? And fractals are deeply embedded in nature, and we know that people actually, the waves in the brain associated with calming down fire more readily when they're looking at fractal patterns. Or was it simply that instead of this view, if they're stuck in a room like this, this is actually a recovery room, so it's a little bit of a not quite a completely analogous example, but you know, there's nothing about this room that's familiar, right? And that's unsettling. So maybe it was just the familiarity of looking out on the landscape. Whatever, all of these different things are in play, but what we know is that all of this took place, the kinds of thoughts, the healing, the so on, the healing better, the healing worse, takes place on a non-conscious level. Okay, and this gets really fun, and actually a lot of this work some of it comes from environmental psychology, but it comes out of cognitive linguistics based in embodied cognition. People have shown that students, for example, who take exams in rooms with ceilings that are painted sky blue score higher on IQ tests than if they take the same test in a low ceilinged room. Similarly, I'm just going to leave that one. Okay, and part of the reason for that is because people, in order to move through the world, develop cognitive schemas on which they rely and use over and over again. So sky blue color above my head connotes a big open sky, connotes relaxation, and produces better cognitive results. There's a lot more work to be said about that, but it's really interesting. So not only is it non-conscious, but a lot of the ways in which our environments affect the way we think, the way we perform in this instance, and the way we feel is not really tremendously logical. There's nothing that makes it logical that having sky blue paint above your head is going to make you do better on an IQ test. Okay, that's not logical. But there's a lot about the way we respond to the built environment and our environments that isn't logical. This is my favorite example. It's not a built environmental example, but it's easy enough to see how it's applicable. this is a study in which students, a whole bunch of students, were given a stack of resumes to evaluate and said, you're a human resources director and you have to evaluate these 10 people on their competence and ability to perform X job. And they handed out all these resumes to 30 students or whatever on clipboards. What they didn't tell the students, or really the study participants, is that some of the clipboards were very, very light and flimsy, like the kind you get at Home Depot or something like that. And the others were really, really heavy. Now, listen to this. What's interesting is that the students who received the resumes on the heavy clipboards consistently scored their candidates as more competent and more suitable for the job than the students who received the same resumes on flimsy clipboards. Okay, so here, this is an instance technically in which our social cognitions are determined by the durability of the thing that we're holding in our hand. Also not logical, right? Okay, since I'm looking at my screen, which means I can't see you guys, but someone yell if you need me to go more slowly or explain something. Okay.
Actually, I'm going to say, Sarah, we're running on into your time. So if you can start wrapping up.
Okay. Well, that makes me grumpy, but I'll do the best I can. Okay. This is important, though. In neuroscience, what we found is that there are certain neurons that fire when we just look at textures or look at elements in the built environment like a handrail, whatever, that would fire if we were actually touching those things. And so things like texture, pattern, materiality, the nature of materials and so on, all become much, much more important to people's experiences of their environment than people ever understood beforehand. The fact of the matter is the built environment is constantly priming us in the sense of non-consciously promoting certain thoughts or inhibiting other thoughts, certain thoughts and actions, or inhibiting other thoughts and actions, just by virtue of the way that it is designed. And I think this is something that we can now say, so we can, to redound back to phenomenology, we can say, you know, it's no longer a theory that we are embodied within our environments in a profound way, and that shapes our experience. It's not just one theory competing among other theories. It's fact. It's the way it happens. And it's something that designers really need to start learning much more about, researching much more about, and take into account in their own work. Okay, I'll stop there and we can get to the rest during the discussion.
Well, thanks so much. I'm sorry to make you rush.
Okay, no problem.
Not at all. But Sonit, if you could share your screen now.
So I'm also sorry to have I was getting quite fascinated listening to Sarah, and actually I would have happily carried on. But unfortunately we had to sort of, there are constraints of time. What I wanted to do was talk a little bit about more narrower ideas, but things that have fascinated me. And let me see if this works. Sorry. For some reason, yeah, okay. So just give me 1 minute. I'm not sure if I am in my full screen mode. Okay, great. Okay, so when Ellen asked me to talk about neuroscience, the first question that struck me was that neuroscience is having a moment. There are lots of people talking about neuroscience. And there is a lot of interest among architects as well. I keep on hearing from people who talk about this thing, the interest in neuroscience. And the question in my mind was, do we as architects really need to know much about neuroscience or think more about it in order to do what we do? My own work has been in understanding a little bit of the kind of tradition that Sarah talked about, applying ideas from social psychology, from psychology, cognitive psychology to architecture to help explain certain kind of things. And we are interested in several kind of explanations that they have to give us about the way we design. But neuroscience seems to be a little bit too much in the weeds, at least to many people. And the question was, can we just stay at the level of science, psychology, and generally what we might call an evidence-based design, the evidence that comes from scientific study of the way they relate to environment? Or does neuroscience itself have something to offer that might help us think differently about what we design? Now, the reason I've got into this is because the question that has always fascinated me is that we can't quite explain why we design the way we do. And the more I think about it, the more I begin to realize is that we are actually not quite in control of our designs. So a lot of designing happens without us knowing about why we are doing what we are doing. That we are, in many ways, a design, if you're an architect and you've been asked to design, let's say, a house, a lot of design is done, or a lot of constraint on the design is put even before you have put pencil to paper, even before you sat before your computer screen and put your first ideas down. And that is the part that I really am interested in following. That's what I've been doing the last few years that I've been working as a researcher. Right? And so the question is, for somebody like me, for doing this, how much is neuroscience useful? Right? The other reason that we should be careful about is neuroscience is a large and complex field. It's, on the one hand, it's quite narrow. It's really about how brain works. How do our neurons interact and how do they produce several kind of phenomena that we see at a more overt, more sort of larger level where we interact. So the question is how, it's a very narrow kind of field. But on the other hand, it's a vast field. And they are sort of, the research in neuroscience comes from one scale from those of doctors who are studying neural lesions in patients. And they're trying to figure out why they are behaving in the way they are. And the other hand, they are biochemists who are studying the level of actual neurons and how do they transmit information. And within that, there is a huge body of literature that's very difficult even for us to get into. So if the literature is so extensive and it's a relatively new science, a lot of developments are in the last 20, 30, 40 years. It's not quite reconciled itself. There are lots of studies which contradict each other, which sometimes conceptually don't agree. So it's a difficult area to get into, right? So one way I thought we should be able to get into it is not approach the world from the point of view of neuroscience, but approach it from our own point of view as designers. What is it about the environment what aspects of environments can neuroscience explain? And so let me start with the thesis. And the thesis is that the built environment is shaped to fit the human mind. This is not an immediately obvious thesis, but this basically tells us that there is something about the shaping of an environment that is not just to fit to our actions and our activities, but essentially about making us understand it before we act in it, or know something about it before we act in it. And these are actually the kind of things I'm just following up from the points that Sarah had made so nicely before. So that's a sort of set myself up. And so if you go further from that thesis, then basically we can think about the kind of aspects of the built environment that we might look for answers for neuroscience. And I think of three aspects that cover a lot of this. There is the layout of the built environment, the way the built environment appears to us organized in space, spread out in space, the look of the built environment, how we see it, and then the feel of the built environment. And a lot of our designing is basically around creating these kind of aspects. And on each of these aspects, what we look at the work of neuroscience, you find that somehow the more recent work has led us to certain realizations, certain points or certain insights that have changed the way we think about the way we operate in the world and therefore in the built environment, right? And that's what I want to follow up today. So I want to a little bit look at where neuroscientific thinking, this kind of down in the beach thinking about the way our brain works, can actually have effects, can have insights that tell us about how we are shaping our environments very directly. And the answer that I want to sort of play with today is a bit surprising to me as well. These are insights that are relatively recent, and I was surprised when I looked at these ideas, when I found these ideas and all that. I could summarize all that with one key insight, and that is that the recent work on neuroscientists shows that it's not a good idea to think of the brain as a general purpose computer, which is what till very recently is how people were thinking of it, especially in cognitive science, but as a collection of highly specialized tools that help us act on the world, right? Sarah had mentioned this towards the end, that perception is about action. And I think that is the kind of line I want to follow a little bit. So what I'll do is I'll talk a little bit about the layout of the built environment and then the feel of the built environment. And I could make similar points about look, but I'll offer two cases, one on each. Okay? So let's take the layout part first. The key question that happens when we try to understand how our environments are laid out is that we need to understand how we learned a layout, right? The basic idea is if we want to move about, navigate, do our day-to-day tasks in any environment, natural environment, design environment, we need to know it. We need to have something in the head so that we can, say, plan our route out, or we can sort of navigate or go from one room to another, or think about and figure where everybody else is, those kind of questions. And for a long time, people thought that the way this would happen is we somehow build up over time a map in the head of our environments. And then when we have built up the map, we can then act on it. So there is a map in the head kind of model that seems very commonsensical, and that dominated for the better part of 50 years, sort of serious attempt at systematic research and understanding how that is done. And one framework that people created was that the learning proceeds what seems like natural steps. So first you recognize points, landmarks in space. And you can think of, if for those of you who know this, Kevin Lynch, for example, is the kind of thinking that's associated with this. So you think of landmarks and recognizable points in environment first. Then you create routes linking them. Then you integrate those routes. And then you create survey type of representations which are more map-like. And once you have done that, you have sort of mastered the environment. You can do various things with it. The funny thing is that this model never really worked in practice. When people tried to figure out, they realized that, for example, Moser in 1988 found that nursing students, even after 3 years of living and working in a hospital, were unable to actually create cognitive maps, draw or present or talk about cognitive maps of their environment, even though they actually had no difficulty in navigating and finding their way through. College, another well-known researcher in this field, psychologist, reported that people who were trained to think about the environments in two ways, first by giving a map, actual plan of the building, and the other people just by moving around in it, did performed about equally, so that a map was no help at all. And then people by 1998, key research in this area, Montello, was basically sort of saying that this map in the head model is not quite working, right? Now, what is the issue, the problem with this? And here is where recent advances in neuroscience sort of come to tell us something quite surprising. So the old model says that we have a memory, we store a map in the environment. How would that be stored? Well, basically, we have to have some kind of device in the head, some kind of, maybe the neurons will figure in such a way that they are organized in such a way that they store some representation of the map. And then we need processes to work on them, to infer information and to make use of it. But we also need some processes to create that map, to input them. But actually, if you look at the brain and the way the brain is organized, this doesn't seem possible in the brain, because the brains don't have anything analogous to a computer, what a computer would do. And the computer memory is created by some device that can stay in a particular state. Even these states are on and off, positive or negative. The combination of those things help us store a memory. But neurons actually don't work like that. They don't have states that can switch or be set in a way to store memories. Neurons either fire or don't fire. And firing is not a permanent state. A neuron that will fire for some time may stop firing and will come back to its original state. So the idea that a map is somehow created in the head seems to be not possible at the level of implementation. Nobody can figure out how that would happen. And actually, memory works in a very different way, as people have found. There's a whole tradition coming from a very famous scientist called Donald Hebb in 1949, who started to talk about memory as being created not by specific neurons, but by connections between neurons, or what he called cell assemblies, and now people talk of as neural networks. And people have elaborated on this. So another famous neuroscientist called Edelman has been working for a long time. There are written popular books also, who talks about these connections having reentrant connections, that is feedback mechanisms. But basically what it turns out is that there are specific neural formations. There are networks that spread through the brain, which are focused on storing very specific features. So for example, one set of networks will only respond to diagonal lines that we see. Another might only respond to certain patterns that we see. Another might respond to colors or tones and things like that. And combinations of these put together features that we see as recognized as objects in the world, right? So that is the thing. Now, if you take this kind of view and you apply to the problem of learning a layout, then essentially what we can do is we realize that we should, instead of thinking about it as a matter of storing information and acting on it, what we actually do is actively engage with the world, and we process information that we need to do. So the way we navigate in the world is not by acting on something that is stored in the head, but by interacting with some things that we have in the head in relationship to what we find in the real world outside. And if we think of the tasks that we actually solve, so rather than think of a map, we can think of a task-oriented knowledge that we are solving. It actually is, things become quite interesting because there are only two classes of tasks that we need to solve in order to sort of move about in the environment. One task is in situ processing. So you are in an environment, you are living in your house, and you need to move from one room to another. You need to find where things are. You need to locate where other people are. So that is in situ processing. And that happens without us actually ever having a sense of map in the head, right? And then there is another kind of task, which is if somebody asks us how to find a way to something, to a place, or you need to figure out whether of the two routes, which one might be shorter, or you might need to reorient yourself. You might sort of discover yourself in a place, and you might need to figure out where the north direction is, for example. In those cases, you actually you need to recall something imaginatively, an environment, and then that's a different kind of task, right? Now, it turns out that there are two different kinds of neural mechanisms that we have to address either of these tasks. The task for in situ processing comes from the work. There's been a lot of very interesting work done by a scientist based in UCL in London called John O'Keefe, who actually won a Nobel Prize on this a few years ago. And he has figured out that in the hippocampus, there are cells, I'll show you in a minute, which basically do this task of creating a map, the kind of cognitive map, but not the kind of map that you would think of. You can think of it more like a set of sensors in the system. I'll explain this in a minute. And that helps us with the in situ processing, the idea of navigating while constantly getting information from the world around us. And not much is known about the other kind of processing that we sometimes do, the neural machinery, at least at the neural level. But we do know from experiments in psychology, cognitive psychology, especially by Barbara Tversky, that the kind of maps that we bring to our mind in order to navigate are actually not spatial maps at all. They are more like schematic figures, and we highly simplify them. We use them as heuristic devices, and they are often distorted, and they are quite often wrong. We are not quite right about them, but there is a lot of leeway in solving those kind of problems, right? Whereas the kind of models, the kind of spatial knowledge that we use for in situ processing is not often wrong, and we can do it without being consciously aware of it. We just navigate without knowing about it, right? So those are the...
Sorry to interrupt. I'm going to have to ask you to start wrapping up.
Okay, yeah, quickly. And so I can this is just an example of O'Keefe showing that of how this kind of thing is mapped. We can come back to it later on. The point I want to make here is that rethinking intelligible, that if you think about it from these two processings, then we somehow begin to realize that actually the kind of advice we have been getting or we have constructed for ourselves on creating good maps to navigate has been quite misguided in some ways. So for example, people have recommended that maps should have good gestalts, symmetries, simple figures, orthogonal grids. This is the example of downtown Atlanta, which has many of these features. those can only help with the second kind of processing, not with the in situ processing. And they fail quite badly, as people have found while navigating in the downtown of Atlanta. In fact, the strange realization is that now it's very difficult to actually find a kind of requirement that can help in both kinds of processing. The requirements are so different that no principles can actually exist to create universally good layout for navigation and orientation, right? And people have done on what kind of principles that you can find. A friend of mine has, a colleague of mine has created work which has said that these kind of, that basically for in situ processing, you need things that are internally differentiated. And this is again work that we can come back to, right? And then and a quick thing into the feel of spaces in homes, into the idea of feel, how the neuroscience can help us understand how it feels. In a study that we did, we found that there are, if you sort of look at in a study of low-income Hispanic residents in a Bronx neighborhood, we found that houses which were centered around circulation spaces, women in that had about, women who lived in houses which are centered around living spaces had 44% less odds of getting depressed than women who lived in houses which are centered around circulation spaces, right? The question is why? What should be about the nature of space in those houses that creates these kind of feelings? From neuroscience, we begin to realize that actually there is a very interesting network called a default network that is activated only when we are imagining things, when we are not focusing on any particular task, but when we are internally representing it. And so from that, we can begin to understand that the feel of environment arises when we are creating a representation of self that is created in an imaginatively constructed space. I could again talk a little bit more about it, but I think we should maybe stop right now, and I'll stop sharing this.
Thank you so much. Okay, Harrison, take it away. Share your screen. My apologies for having to rush everyone.
I share the screen. Why won't it share?
No.
When I click on share the screen, I have my thing open and I try, there we go. Here we go.
All right.
I'll try to go really quick. I knew, my old. So I'll go really quickly here so we can get into a conversation. But I was interested in this because I taught a theory course at Princeton, really involving perception and cognition, and was interested in Piaget, Gestalt psychology, phenomenology, the environmental psychologists. And I also was really interested in neuroscience because aesthetics and the sensorial have been largely missing in the discourse on sustainable urban design because we focused on integrated systems and a technical fix. I also read a wonderful book by Sarah Robinson, Mind and Architecture, which really argues that the insights from neuroscience and embodiment theory imply that we should rethink urban design. Also very frustrated that the environmental performance of public space is really underdeveloped. Public space has been conceived many different ways, and that we could really capture the sensory and aesthetic potential of sustainable systems in making public space more meaningful. So let me tell you what I took away from neuroscience. Number one is the desire for meaning is really primal. It's been part of our evolutionary history. It's very pre-conscious. It's not just the subject of the cultural elite, but meaningful for all participants in the city. Most importantly was the discovery of mirror neurons, so that when you see a cup, it's not just a visual experience. It activates neurons in the motor and premotor cortical areas that would be activated if we actually picked up the cup, held it, and drank from it. So there's a subconscious thing going on besides just the visual image. And also that meaning is embodied in the functioning brain, where J.J. Gibson has said that objects are and mean the possibilities for experience, both actual and simulated, that they afford us. And meaning is not just some abstract, disembodied conceptual content, this model in the brain, but rather involves neurosimulation of sensory, motor, and affective processes. So
Harrison,
yeah.
Harrison, we're not seeing your slides advance, and yet I think you've been trying to advance them. You probably want to go full screen too.
Okay, so how do I do that?
Full screen.
I think what he needs to do is do the slideshow.
The interesting thing is, I see. I can, if I do this, does that advance it?
No. We're not seeing we're just seeing that first screen. So Carmen, what's your suggestion?
Did I escape and start again?
Yeah, that's actually what I was going to ask you to do.
Okay. So here
wait,
it is.
now we can see the next slide, but so if you're just, I think, touching something you did.
Does that be the next slide?
That's good, that's working.
So if I go to full screen though, let's see if I do that and try to advance, does it advance?
Probably.
So does that advance?
It didn't go full screen.
Seeing it as full screen.
No.
It hasn't gone full. Well, mine is full screen now. I apologize. Blue Jeans just seems to be glitchy today. We can see the slides and you're advancing them. They're just, but that's okay. So why don't you just keep going? On this one, yeah. Sorry. I've already said these things about the desire for meaning, the discovery of mirror neurons, that we actually simulate the activity of holding a cup and drinking from it, not just the visual images. And that meaning really comes from this simulation, as J.J. Gibson has said, the affordances, what something invites and makes possible. So meaning is not just this abstract thing in the brain, or disembodied. It really involves neurosimulation. And if you look at the pictures on the side, we feel the struggle in the Lacaun. We actually feel the motion in the dance. We feel the weight of the stone in the Magritte. We understand the cut in the Matta Clark house and the slump that happens. And we feel the scrape in a Richter painting. All of these things are embodied and preconscious in our perception and cognition. Neuroscience also really emphasizes that these two hemispheres are so important. They allow us to have two ways of being in the world. One, the left side is very narrow and focused and rational and either or logical, and the right side is very broad, expansive, sustained, nuanced, tries to understand complexities, and these and we alternate between these ways of being in the world below consciousness. But they also show that there's a hierarchy, that the global attention comes first. So the first impression of the environment, the feeling, underscores Merleau-Ponty's emphasis on the unity of the senses. I perceive in a total way which speaks to all of my senses. What creates meaning? We also bring image schemata, even going back to Piaget, which we've learned through our interaction with the body, mind, and the environment. So containment is fundamental. Verticality, we live in gravity, we can jump, we feel, we drop things. Balance is critical in the environment. We've learned that. We've learned about forces by lifting things, dropping things, knocking things down. So when we see a building collapse, we feel all of that at an unconscious level. And motion has been fundamental in our experience of the environment. And it's not just our moving, but our understanding and projecting ourselves moving. And you can see that what's so interesting about this embodiment notion is that the normal concepts like point, line, and plane, which normally were just seen as visual, we actually simulate the drag of the point to create the line, the drag of the plane to create the volume. And then we can even see that in subtractive forms where we actually simulate the cutout, or we can see the added forms, or we can even imagine the transformation processes that have created something like the fold or a shift or a rotation, etc. So what this means is that if you actually look at some well-known spaces that really have incredible environmental performance, like Paley Park, our mirror neurons, we simulate the gestural notion of the forecourt and the enclosure of the room. We are invited to occupy this space in multiple different ways. So it affords many ways of existing in the environment, which we feel subconsciously. And then the environmental performance is extraordinary. The shade, the evaporative cooling, the evapotranspiration of the plants, and all of this is embedded in our senses through sound, smell, the actual touch, the simulation and the touch of the materials, the feel on the skin, and the dapple light. So this has this incredible atmosphere and character that we feel in a visceral, omnisensorial flash of knowing. It's really a memorable place. You can see these insights in operation. The same if you look at Scarpa's Biennale courtyard. We come out of these galleries, we see the sky, we feel the enclosure of the space. We try to understand this balancing soffit that sits on little points, and then these little opening at the edges, which create amazing little subspaces. But what's so incredible are the smell, the sound of these fountains, and then the reflection up on the soffit. So the sensorial experience really enriches and kind of embeds and implants the aesthetic experience in our bodies. Problem is that public space has had many different concepts. It's been seen as a formal spatial performance, a space of social performance, a space of transit performance in all modes, and also a space of infrastructure, where primarily the performance is to be a throughput, get rid of things, but now it's one of retention. What's so interesting is if you look at the environmental performance of public space, I won't go through all of them, the first 10 ending on really health, aesthetics, energy, habitat, food, stormwater, CO2, air quality, microclimate, these are all underdeveloped and a tremendous design opportunity. And it's best to look at this spatial environmental performance in section. Right now, normally, the public space of cities has been a dumping ground for waste heat, for sunlight, vehicles exhaust and heat. But if you look at it, you look at the urban section, you realize that the envelopes and all the surfaces and the public space can be designed as an integrated whole. We rethink all the surfaces and systems. The book goes into the fact that there are so many wonderful examples of how these surfaces have been rethought. The floors, the walls, the canopies, and the roofs. I won't go through them all, but they all have eco-functions, they all have co-benefits, but most importantly, their aesthetic and social value are still underdeveloped. So what we try to do is take some of these systems and show how you might take fairly well-known places like the Plaza Real, which had a new layer carved out of the medieval city to create this neoclassical space, but it's a terrible place in terms of environmental performance. So we added a new environmental layer, which you can see, which generates energy, shades the facades, so you don't have the urban heat island effect. And then we created the orchard that used to be there at one end and a fabric shaded, evaporative cooled area at the other end, to show the incredible potential of these systems to not only change the environmental performance, but to make the place even more meaningful. The same could be seen in Harlem if we change the cross streets, reflective paving, permeable parking on a diagonal, planter swale, tree canopy, dramatically increased windbreaks, movable fabric awning. You can see what happens on the avenues when you have an awning during the day and it's open at night. You could also turn the wide streets in New York into a power plant, a shading device, and a hanging garden. The point is that all of these systems have amazing potential if thought of with a new sensibility from neuroscience, which really pays attention to the visceral and rich environmental experience to make places more meaningful. So this book tries to outline all of these things. It suggests that this is really in its infancy, but there's a potential for a whole new urban design toolbox, and that this potential it really comes by minding the city with this new embodied sensibility for its latent potential of environmental performance, and it'll create a much more sustainable, humane, and meaningful city. Thanks.
Right. Oh,
I did that in 10 minutes.
14. That's but not bad. No, it was great. It really fabulous presentations. I feel terrible having to rush you guys. We
okay,
are.
so we'll stop sharing.
Yes, please, Harrison, you stop sharing, and I'd like to invite Sarah and Sonit to also turn their videos on, and I will turn mine on. And we are past our time, so I'm going to allow. So obviously, I have no control anyway. But if anyone wants to leave, they should feel free. But I think the speakers are willing to stick around, and we'll have some discussion, and we'll be very happy to answer questions. So if you can stick around, please do. So my first question actually is to really invite the three of you to compare and contrast. What are some of the things you learned from each other, or which of your neurons were sparking on what aspect of each other's presentations? Who wants to to comment?
Well, I think let me just say that what Sarah does so beautifully is link these pre-conscious ways of our interaction with the environment to health, and the fact that we need to design places that take all of these dimensions into account, especially the sensory, the kinesthetic, the gestural, and the affective. And that really is a powerful enhancement in terms of human health. And in fact, the health community has recognized this. They've argued that the design of the built environment is more powerful than in terms of promoting health than even drugs. But it has to be designed with these kinds of sensibilities at play.
I'll just add to that. Thank you, Harrison. That one slide that I didn't get to because I should have edited more than I did is the slide about enriched environments. Which I think is really, really critical for this. I mean, one thing we know from studies in rats is that the more multi-sensory stimulation and the more different varied types of affordances that environments give, the mice that are in environments that have those kinds of opportunities, those kinds of stimulations and so on, their brains are actually bigger and better.
Yeah.
And there's no reason not to think that that's not true, that an enriched environment for a rat, that principle doesn't also work for the kids in East Harlem that live up the street from me.
Exactly right. That's the key thing for me, is this is not just an elitist thing. It's
No.
relevant for everybody.
Yeah, and
No,
actually if I can just say, we have just finished a study. We are doing the study with some people in occupational therapy, where we have studied elderly living in a place, and we have found that if you just count the number of doors in the house, and I explained in a minute why, number of doors correlates with with their performance on mental scores.
that makes perfect sense to me.
And the idea is, more number of doors, you get more rings in the house, more circuits. And the house which is more circuits is one aspect of what an enriched environment would be like, as you are planning your way around. And we have found, and this is just a preliminary study, so we don't know how strong the results would be. But there is an immediate, so the thing is, there are nice ways of translating exactly what you said, the idea of enriched environment into health. And then we are beginning to find, if you do this, we are beginning to find slightly surprising results. So
Yeah.
just to reinforce the point that you made, yeah.
So to support that, we looked at 8 case studies. We could have picked hundreds, and really confirmed the amazing importance of these, the value of having an enriched sensorial environment that reinforces so many things, but also this idea that the gestures of the space are really relevant, that our mirror neurons recognize certain kinds of facial form and gestures, and that's exceedingly valuable. I mean, I wish I'd shown the amazing transformation of Lincoln Center that Diller and Scofidio did.
Yep.
That changed this thing that was remote from the city up on a podium, brought it down, opened it up, reached out, created a shaded bosque, a sunny lawn, all of these things that completely changed the environment and afforded many ways for the public to occupy this space rather than just go to a concert.
And what's critical to say, I mean, it's like, in my understanding, Harrison, it's more canonical neurons than mirror neurons, which is the canonical neurons are the things that fire for objects rather than for people. But in any case, I think what's really critical to say is people don't even have to use them.
No, that's the whole point, that the mirror neurons simulate. I mean, when we see something, we don't necessarily have to participate, but we imagine it. What happens is, I think what the neuroscience is showing us, that we have this amazing thick moment where we are in the present, we have all the sensory and environmental stimulus, but we bring the memory of similar things to it, and we imagine ourselves participating in this. So
exactly.
Perception and cognition is this amazingly rich, thick moment of both past, present, and future.
Mm-hmm. Exactly.
I'd like to hear you talk a little bit about how in your book, you talk also about how, in addition to an enriched sensorial environment, helping literally grow the brain, sort of a healthy brain, but also actually helping us act on it. And you talk about empowerment. And Harrison talked a little about affordances, and I see those as quite as similar, but could you talk a little bit more about it?
Well, I mean, there's so many different ways to talk about this, but I think one thing that we're not talking about just because of virtue of time, but is important to say, is that the reverse of all of the principles that we're talking about is also important, which is that bad environments deplete people cognitively and emotionally.
Yes.
And we have evidence of that as well. So it's not only, gee, this is a really nice thing to do, it's a must-have, because otherwise you're literally diminishing people's capabilities. And I use the word capabilities in the Amartya Sen, Martha Nussbaum sense of what is the responsibility of a polity or a society of a nation? It's not just to make sure people aren't starving and make sure that they're not, dying to death of thirst and so on and so forth, but to allow them to actualize their capabilities.
Yes.
And if we move to that model, which is the model that even the UN is moving to, when they're scoring different countries on how well they're doing on various things, if we move to a capabilities model, then we cannot ignore this.
Sarah, what's so wonderful about that is it's only recently, I think in the last 2 years, that the UN Sustainable Development Goals recognized that public space is one of the most crucial elements to take seriously, to have the highest ambitions for it, because for the world, in many cases, this is where they live.
Right. Yeah, right, exactly.
And we should be making spaces that maximize their potential.
Yeah.
Using this sensibility, and I've argued that this, neuroscience isn't going to create a poetic place.
No.
But a neuroscience sensibility has the possibility of creating a even more rich poetic place if, done with the imagination, where all of a sudden, you're in a special place, you're not quite sure why, and maybe the left side of the brain over time will discover all the reasons why, but you suddenly are in this amazingly rich place that keeps it in your imagination, in your memory. That's why
what I call sticky spaces, yes. I'm sorry, this is something I often refer to as sticky spaces. What public spaces needs to be sticky spaces.
They're why these places have maintained their iconic, recognized value. Why is Paley Park? It's 50 years old.
Yep.
And it's a wonderful example.
Mm-hmm. Yes, it is.
It absolutely is. Well, and I think it's easy for us to see these sort of after the fact, apply the neuroscience principles to places like Paley's Park. But I'm really fascinated with Sonit, really kind of doing research at the scale of buildings. And so looking at the living room centered layout versus the corridor centered layout and finding depression rates here in the corridors. Do we have studies? I mean, it's really pretty hard. How do you measure do the studies at the scale of a city with so many more people? Are there some out there that have really looked at health and brain activity Merleau-Ponty, interestingly enough, also threw out the idea of a plural subject instead of just focusing on the individual subject. And I think kind of almost what my question is are there studies that really, we can measure it when it's at a small enough scale and we've got a sample we can kind of control, but are there ways to measure it at the urban scale?
So, of course there are ways to measure it.
Is anyone doing it?
There needs to be the political will or the social will to do it. And there are they're basically institutional and structural reasons by why such studies very often don't happen. It's actually something I'm working on a lot. But it's not that hard. All you have to do is convince a few urban design firms that they are going to get more clients if they can produce the data.
Yeah.
Once they invest in post-occupancy studies, and then which Gale Architects already does, but they use mainly environmental psychology. So it's not an insurmountable problem. It's a big one, but it's not an insurmountable one.
Yeah. Something we had been talking about earlier was that architects have the subject of aesthetics has always been of interest to architects. They're not always explicitly really learning about it or talking about it, but they're always interested. Planners tended to be worried about us. That tended to be a little much more suspicious of adopting aesthetics, and yet they are interested in. They want the design quality, but as soon as you say aesthetics, it seems either elitist or it seems just too subjective. And yet, so it's so important, I think, the messages that all of you guys are bringing.
I in the book I do talk. You can't avoid saying something about Kevin Lynch and the image of the city. It would be really fun to go back and do a post-occupancy evaluation of what really made a place a landmark, what really made a place an edge, what really made a place a district. And you went in and tried to identify the multiple levels of engagement in those places to see if you could identify some of these factors as being agents or operative in why these things were identified as edges or landmarks or districts or paths, etc.
Yep.
It would really be interesting to do that kind of follow-up.
Mm-hmm. Good. I know my own education, Architecture 101, that I took, one of the assignments was we all each had to do a Lynchian analysis of sort of our kind of, route.
World. Yeah.
I'll just say on Lynch, this is a few years ago into my research, and I haven't looked at the notes since, so I'm not going to be able to cite chapter and verse. But what I found in the neuroscience on wayfinding and place identification and place attachment is that those concepts that Lynch came up with held.
Yeah.
They were neuroscientifically correct, which I thought was, whoa, that was really cool.
Yeah.
So how do we get this more into the education of architects and planners? Sonit, go ahead.
Yeah, no, I was just going to sort of say, maybe we can talk about that, but I've been listening to you and sort of very fascinated, but maybe let me ask two difficult questions that have always struck with me because I've tried to work in this field. So in a way, I'm very committed to this field because that's the area of my research. I've been trying, and obviously I've not done much work in as a designer or something. So there are two things that have struck me and always have made me both curious, but also sometimes a little bit discomforting. They're difficult questions. And one question is this: why do we have such bad environment after at least 2 or maybe 5,000 years of building? Why have we not come up? Or forget about that. In 100 years, when we think of somebody like Corbusier, who was very much in tune with what was happening in the world of psychology, Gestalt psychology. So there was the idea of incorporating studies from psychology, from visual studies into architecture has always been very alive, at least last 100 years. And yet every time we sort of try to put this, we come up with environments which are not very successful. I mean, one of the studies that I didn't talk about that I was going to was the Breuer building. Breuer building came out of very good work on what makes buildings interesting visually, aesthetically. So that building is a result of applying psychology. At that time, the state-of-the-art psychology to architecture. And yet after 20 years of that building, a lot of people don't really like what they see in that building, right? So that has always puzzled me, is what is it that has made this idea not work in practice? Why is it taken so much effort that now in 2020, we are still talking about how do you bring scientific evidence into play in design? And I feel that that's not an easy question. That troubles me a little bit about what I do. And then the other question is, and maybe it's related, is why is it that, how do you translate what you see is the difficulty of translating scientific research into practical advice for designers? I've really struggled with that because the more you go into good studies in psychology which establish something, they are at such a micro level that it's very difficult to say, and those are done in very tight constraint. The better scientific study is done in better constrained circumstances. You take out all the other things. So how do you take something that is to prove that is such a fine, and that in a way, I'm sorry, but that connects to the point that Ellen was making earlier, which is, the idea that you study something at the level of one individual. You can't really, you should not, I'm not sure if you could really say that if we design a better city, everybody's health will improve. I can say if I design a better city, maybe the mental health of the person in their home can improve. But I cannot say everybody in the city will be healthier and on an average than somebody else. That's strange. So those questions worry me, how to translate research into practice, and how is it that things don't work out? I don't know if you had, Harrison and Sarah, if you had anything to add to that question, or if it troubles you, or if I'm overthinking it or something.
You're not overthinking it.
No, in fact, the trouble is it's been underthought. You have to remember that the Environmental Design Research Association, which was the very beginning phases of trying to deal with psychology and environmental psychology as a scientific effort to help us understand our relationship to the environment. It's 50 years old. And to some degree, I think what happened with designers is they got sort of buried in the weeds of it and didn't appreciate some of the larger implications of it, which is why I tried to write in my book not about the science and all the studies, but what the insights imply for urban design, rather than, the hard work of validating the role of mirror neurons, or exactly how affordances was come to be understood in neuroscience. It's just the implications for me as a designer and for my design students that I think it's so important. And if you look at, let's take not architecture sort of, I would say, got seduced into, abstract, semiological, linguistically argued formal games for a long time, and forgot about the visceral and sensory engagement of the environment and how we actually move around in it. But if you look at urban design, what do we have? We have a fascination with abstract figure ground games. We have big data, and we aestheticize the graphing of big data. And all of this actually does help reorient our understanding of the city, but it forgets about what really matters for people in the urban environment, I would argue. And that's why, I've tried to argue that this embodied sensibility from neuroscience ought to bring us back into what really matters when we're making urban places. And the health implications are staggering. And my book doesn't emphasize that, but it would be a great addendum to it. And I really appreciate Sarah for making those linkages in your book. It's really, really important.
Thanks. Yep. Well, I look forward to reading yours. Go ahead.
A couple of questions from the audience that I think are sort of getting around some of getting to the same topics that just been discussing, and some of the questions certainly, Sonit, I think Sarah did a great job of, saying, well, okay, they found that people got healthier looking out a window at a pastoral landscape, and you raised all the questions because we don't really know the precision of really, it's not a cookbook that's giving us a recipe.
It's not going to be.
Yeah, and it won't. Exactly. And we are different. Thank goodness. Who wants the world to only be one design somehow?
Right.
that we have deemed to be the right one. But some of the questions are beginning to ask whether, one of our students here, do you think the feeling that people have about the environment is also affected by what kind of environment that individual is familiar with? So is it, the difference between, say, a commercial suburban strip that most of us would characterize as not a particularly enriched sensorial environment, versus a pedestrian urban walking street or something like that is tuned to a pedestrian. Are those kinds of, I'm sort of merging a number of different questions together a little bit, but the difference, let's talk a little about the difference between cities and suburbs in terms of these topics.
Well, let me go to the first part of that, which is the how about my modal person in Namibia, where I spent some time? Total desert landscape, black skin, et cetera, hot climate. Are they going to need the same thing architecturally, urbanistically? My answer is a kind of an on the one hand and on the other hand answer, which it has to be. And I think that, so often in the academy, although people want some kind of solid place to stand, like cultural construction is essential, and you have to make environments that are sensitive to people's culturally constructive social and cultural experience, right? And that's true. And we're all humans. We stand up straight. Backwards is behind us. It's a little bit of a stary space. We see forward. Up is good. Down is somehow bad. I mean, so it's a both and answer, which is, yes, of course culture is important. And we're all animals. And animals evolve in environments in profound relationship to the environments. And so sorry, it's not such an easy, like clean answer, but we can deal with that. Go ahead, Harrison. Sorry.
I totally agree. The take that I had on neuroscience, the last little discussion has to do with, emotions and memory. And cultural difference is the cumulative memory of our cultural experience.
Right.
And we bring that to these different places. So you're going to have very different readings because of this, subconsciously. But just like you say, the readings may be subtly different, but we'll find in some places that even culturally varied people will find these places memorable, pleasing, engaging, because of the affordances, et cetera, et cetera. So,
exactly.
Yes, there are no absolute answers, but there are some important things to recognize. And if we can, what would be so interesting, I've been to Namibia too and gone all around it. It's the most amazing place.
Incredible.
Place I've ever been. And their schemata, their image schematas that they've developed from living in that landscape have got to be somewhat different than the stereotypical ones of Western culture. And so how you make something meaningful is understanding their hierarchy. You can empathize with their hierarchy. You may not know it, but they may design differently because certain things are of more importance than other from their history and emotional engagement throughout their lives with the physical environment. So again, these insights from neuroscience aren't going to point to any one solution. What they're going to point to is how somebody can find things in the environment that can make something meaningful and poetic.
And the other thing I would, sorry, go ahead, Sonit.
Go ahead. I was just going to say that the way I would think about Ellen's question is it's nice to separate two very distinct functions of our built environment. And there are some functions require two different things that they don't always merge together. So one of the functions of the built environment is it helps us live our lives better at all levels, emotionally, mentally, aesthetically. So aesthetics comes into play and everything is nice and comfortable and if things are settled, familiarity matters, right? There's one thing. And the way we deal with that is we are not consciously conscious of the environments. We are just using it and it doesn't interfere with what we do. It enables it. And then there is another kind of function of the built environment, which is where it's comparable to literature, writing poetry, let's say, which is to create, maybe even make us uncomfortable, but make us think, engage, and sort of.
Yeah.
And the thing is, those two have very different demands from us. They don't always come together. We could not do these kind of studies. Like you can do neuroaesthetics of how do you learn and sort of read things, but that cannot help you write a better poem, right? We are not saying how can you write a more efficient poem. So that demand from studying how our psychology works to answer one kind of a thing, which is where your attention is not required, where you do things without thinking about it. That's one kind. And then there is other thing. And the funny thing is because both come together, that is where all the complexity in the environment comes. An environment which will do one thing well will not do another thing very well. You can write a report that is easy to read, everything is clear, and it has its own charms. But of course, if you write using the same principles, piece of poetry, that will be boring, it'll be dead. And the poetry can be very complex and demanding, but you cannot live our life with everyday things we do like this. And the funny thing is sometimes they're separate objects, but a real life, a house that I live in, can do both the things at the same time. Or it asks me to do both.
That's the important thing.
That contradiction is what creates the problem with not being able to employ it. That's how I would think about it.
Last question, just a quick round robin, closing off with your advice to future students of cities. Whether they're architects, planners, urban designers, psychologists, neuroscientists.
I would invite future people to study, to go into academia, to do some research, because we need the translatory research. There's a lot of research in these fields, practitioners, but we don't have people in the middle who can do actually the kind of thing that Sarah and Harrison, both of you have done. You did this because you felt there was a need to produce a book that takes research being done in one area and makes it accessible. And I think that demand is not simply that of, I think there should be a program of study. It's as difficult a thing to do as doing actual research. And I would invite a lot of students to spend maybe make a career out of doing that. That would be my thing.
Hear, hear.
Yeah.
I second that motion. One thing I can say is when I was at the GSD, a lot of the faculty, this is a long time ago, so I can say these kinds of things, were quite dismissive of sustainability. Like, only really shitty architects do that. We don't need to pay attention to that, so on and so forth. And I was on the admissions committee every year. And every year, year after year, more and more students would write in saying, sustainability is really important, and that's what I'm coming to Harvard to study. Yeah. And guess what? They finally put faculty on there, and they made a whole program to it. And I think that that's what needs to happen with this body of literature. The more people ask for it, because it's the students that change things. The more people ask for it, the more people educate themselves and sort of push it forward, the better it will go.
So my hope would be that this little dive into neuroscience, that students will appreciate that sustainability really has an aesthetic potential, and its sensory dimensions in all the senses, whether it's 6 or 13, depending upon who you read, is really, really important. that the aesthetic dimension of sustainability is just starting to be appreciated, and its potential to really transform cities is remarkable as part of an integrated technical systems fix of the cities that we need to do. So that would be my hope, that the students really go after. They have to learn how the systems work, but it's really their aesthetic potential that is, I think, going to be the most lasting and enduring.
Mm-hmm.
On that note, I want to thank you all very, very much. I thank the audience for staying with us. I apologize for some of the glitches with the platform today and the slides, and I apologize for having to rush our speakers, but we actually had, I think, a terrific conversation, and I'm so glad we got to it. Thank you very much, Sarah, Sonit, Harrison. I look forward to more Redesigning Cities episodes in 2021, and I think we're all kind of looking for 2021 is going to be an interesting year.
Yep.
Nice
to be with you guys. Really appreciate it. Lots of fun.
It was very interesting. Thanks so much. Best of luck with your work. Bye.
Bye-bye. Yep.